Okay, we're just going to keep looking at some examples that really show the relationship between linear functions and proportional. And a lot of it's going to focus on, does it go through 0, 0? Or does it have an initial value? And that's what we're going to kind of be focusing on, as well as writing equations like we have been. So, example 3. Water flows from a faucet at a constant rate. There's that keyword, excuse me, 7 gallons every 2 minutes. Okay. The bathtub is initially empty. So there's nothing to start with, right? It's initially empty. Determine the rule, that's the function that we're going to write, to describe the volume of the water in the tub as a function of time. And then we'll come back and answer this question. So remember, minutes go on the bottom. So we're going to say 7 gallons in 2 minutes equals y divided by x. And then just like we've been doing, right? 2 times y using our cross products equals 7 times x. Then we're going to divide both sides by 2. 2 divided by 2 is 1y. 7 divided by 2, we'll just say is 3.5, 3.5, right? Times x. Y, remember, is the gallons. And x is the minutes. Now, you can leave it like that. You can feel free if you wanted to change it to like g equals 3.5 times m, maybe for minutes. That's fine too. Okay, either way, just recognize what the variables stand for. And the reason we want to do that, okay, is because this next part here says if the tub can hold 50 gallons of water, how long will it take to fill it? Well, 50 gallons. Does that go in for y or for x, g or m, however you want to think of it? And so it's really helpful because, well, 50 gallons, that means g is 50. That means I'm just going to plug that in here for g. And I'm going to get 50 equals 3.5 times m, and then I divide both sides by 3.5. And we end up with m is approximately equal to 14.2857. So we're going to say approximately 14 minutes. How long will it take to fill the tub? About 14 minutes. Okay, look familiar, right? Hopefully the work you see is from being familiar. Here's semi-new part. Not really new, you've dealt with it, but maybe just not identified it. Now assume you're filling the same 50-gallon bathtub with water flowing at a constant rate of 3.5 gallons per minute. We got that here. But there were initially 8 gallons of water in the tub. Will it still take 14 minutes to fill? All right. Initial value is really important because now, notice there's no initial value here, okay? But I can rewrite this equation, right? It's still traveling at a 3.5 gallons per minute, but we have an initial value. So it's basically our y-intercept, right? In slope-intercept form. Okay, whatever is being added on now, that is going to be our initial value. It's our b in slope-intercept form, okay? There is no initial value here. Well, there is, but it's 0. Okay, so we're really just another step of writing the equation. If you know where something starts, that's where you're going to add on to it. Our initial value is our b, it's our y-intercept, okay? Again, if I wanted to, I could rewrite this as g equals, well, I'm not going to in this case, just because I just peeked down here at the chart and saw that it's still using x and y. So we're going to remember that y represents our gallons still, and x is our minutes. And now we're going to just input our x values, our input values, into this function. So we're going to say right here, remember this is our x value, we're going to plug that into here, and we're going to go 3.5 times 0 plus 8. Well, anything times 0 is 0, 0 plus 8 is 8. All right, now let's input this 3 in. I'm going to go 3.5 times 3 plus 8. Really sloppy, apparently. And when we do that, that's 18.5, 18.5. And then I'll go 3.5 times 6 plus 8. And if I just type that into a calculator, that gives me 29. And just to finish off here, 3.5 times 9 plus 8, which is 39 point, no, not 35, 39.5 3.5, and then 3.5 times 12 plus 8, which is 50. Okay? So let's go back to the question now. Will it still take about 14 minutes to fill the tub? Well, the tub is filled, remember it's a 50-gallon tub, right? So it's going to be filled right here. So is it going to take 14 minutes to fill it? No, because we had that 8 minutes in to start, it's only going to take about 12. All right. Okay. So again, now we've introduced this idea of initial value. Okay. So if it starts at 0, 0, proportional. If it has an initial value, remember now it's just a linear function. All right. A couple more examples. All right. A linear function has a table of values below. Okay. So you can see it shows the volume of water in gallons still. That flows from a hose this time. We're not filling anything. And the number of minutes it's been running. So for 10 minutes, 44 gallons, 25 minutes, 110 gallons. Okay. Write the rule. Write a function for the volume of the water in gallons. Okay. Now, what we want to check first to see if there's a constant. Because if there's a constant, we know it's proportional. It goes through 0, 0. So, how do we do that? Well, we find our constant, y divided by x. So I'm going to say is 44 divided by 10. It's 44 there, sorry. Does that equal 110 divided by 25? Does that equal 220 divided by 50? And does that equal 308 divided by 70? Okay, just like we used to back in 7th grade. So if you divide all of those, you get every single time 4.4. Okay? So you could go back, sorry, click the wrong button. You could go back and use like the proportional way of cross product setting things up, or if we know our constant is k, our constant k is 4.4, I can just plug that in and I can just write y equals 4.4 times x. Because remember, what does a constant do? It's what we're multiplying by each time. It's what we multiply 10 by to get 44 and 25 to get 110 and so on. Okay? But I am going to remember here that y is gallons, right here, y is gallons, and x is our time in minutes. Okay. All right, so what number does the function assign to 250? That is, how many gallons of water come from the hose during a period of 250 minutes? So if we're talking 250 minutes, that means x, our minutes here, is 250. All I'm going to do now is input 250 in for x right here, and then just off. Okay, don't overthink it. We're really just substituting numbers in. We're inputting numbers into a function. We multiply those together. We get y equals 1,100 gallons. Okay. So continuing on with this, the average swimming pool holds, okay, so we're going to keep using this formula right here, okay? It holds 17,300 gallons of water. So we're going to suppose a pool has already been filled 1/4 of its volume. 1/4, 1/4. We want to figure out what 1/4 of 1,700 and 300 is. So if I just multiply that together, or I can take 17,300 divided by 4, I can change this to 0.25 and multiply it, however you choose to do it, we come up with 4,325. It's already been filled that much. So guess what? That's our initial value. This is where we're starting from. And remember, our initial value is what we're adding on to it. So I'm going to update this formula. Okay, I'm going to update this equation right here. And I'm going to say we're still filling it at a rate of 4.4 gallons per minute. But I'm not starting at 0. I'm starting at 4,325. Okay, so we're just taking the equation to the next step. Okay, this is how many gallons we have. We go 4.4 times the number of minutes plus how many gallons are already in there, 4,325. So approximately how many hours will it take to finish filling the pool? Well, if it's full, that means the number of gallons has to be right here, 1,700 and 300 gallons. So guess what that is? Gallons is Y. So now I'm going to take this number, I'm going to plug it in for Y. Okay, that's why it's really important to know what Y represents, what X represents. And if you're given a table, it usually tells you right here too. All right, so real quick, I'm going to solve this equation. Okay, I'm going to plug in 1,700 for Y. That equals 4.4 times X. That's a decimal point. Plus 4,325. Solving for X, I got to get rid of this 4,325, so I'm going to subtract it from each side. And because I've already done this problem, I know that when I subtract that, that works out to be 12,975 equals 4.4x. That cancels. Divide both sides by 4.4. And I'm going to get approximately, my x here is going to be equal to approximately 2,949 minutes, approximately. But it wanted to know the hours, so I'm going to divide by 60. Okay, and when I do that, the number of hours is going to be still approximately, but approximately 49 hours. Sorry, that's all squeezed in there, and that's 49. Okay, so it's stuff we've been doing. Don't overthink it, but we're just talking now about whether it's proportional, meaning it goes through 0, 0, or if it still has a constant, then it's just a linear equation or a linear function. And look at this. We have slope-intercept form, y equals mx plus b. So we have this table here, right? 0 goes to 4, 4 goes to 24, 10 goes to 54. So it's a function. All our inputs have different outputs so far. And it wants to know what is the equation that represents the function. So here is a hint. Okay. If you have an input of 0, that's where it's starting, right? Think of the number line. Or think of a coordinate plane, right? Where's 0 at? Right? We haven't moved left or right at all. This is where we're starting. This is where our y-intercept is. So this right here, this is our initial value. Okay? Actually, it's the 4. The 4 is our initial value. It's what goes with the 0. Okay? Because we haven't started yet. Where are we starting from? Starting from 0. What's our value there? 4. So if you have that, then you can, just try to figure out. We know y equals something times x, and then we're adding 4 to it. So work backwards here. What if I subtract 4? Subtract this 4 off, I have 20, right? What do you do to 4 to get 20? Well, you multiply it by 5. Does that work over here? If I subtract 4, that's 50. What do you do to 10 to get 50? You multiply by 5. If I subtract 4 here, that's 55. What do you do to 11 to get 55? You multiply by 5. Okay, so the initial value we can take off and then figure out what we're multiplying by. So completing the table, I just got to plug things in here. 5 times 15 plus 4, that's 79. Inputting it for x, 5 times 20 plus 4 is 104. And 5 times 23 plus 4 is 119. Okay, so again, the difference between really being just proportional and just being a linear function is that fact that is their initial value. Okay, if it goes through 0, 0, it's proportional. Okay, if there's an initial value, then we know it's a linear function. Just watch that when you go to write your equations.